Hi everyone, thanks very much for letting me present at the conference. My name is Marc Funnell. I'm the Director of Digital and Detti at the National Composite Centre. What I'll be talking you through today is the digital journey that we've gone through over the last 3 to 4 years as we transform the National Composite Centre into a digital exemplar for industry. So what is the National Composite Centre? Well, we are a part of the High Value Manufacturing Catapult. We are based out in the southwest of England, in Bristol area. Our focus is on the innovation of composite materials, but we have a test bed for composite manufacturing as well as for digitalization and for sustainability. We are a factory, but we are an innovation center, and we look to enhance the capabilities of composites and also digital for composites, which is our specialist area, but we are not only and solely based on composites. We are over 21,000 square meters of a facility with a significant number of world-leading assets in the composite manufacturing space. Our digital opportunity and the missions that we set ourselves are really based on these 4 challenges. We see the landscape of products changing, and with the net zero targets, sustainability, ecological living, and all the missions that are being coming in from a UK national perspective, we need to start thinking about how we radically change the products and do that in half the time, or significantly reduce the time by which these products are introduced into markets, and that way make a step change in the net zero target. We also are a manufacturing site, and we focus on net zero manufacturing, which is there to really increase our production rates, but also look at low cost demands that are associated to it. We're also focusing a lot on sustainability and our ability to introduce sustainable products and sustainable materials into the process, as well as achieving this step change in productivity, our ability to build more with less. But our core focus areas for digital is not just focused on composites, it's around manufacturing as well as product development, around the life cycle of engineering, about how data and how products utilize that data, ingest that data across the life cycle. So we're focusing on re-engineering the way we talk about engineering and really transforming the product development process itself, looking at it from an holistic and a wide range of aspects, all the way from conceptual development, all the way through to validation, life cycle analysis, and focusing on how we accelerate design and really this concept of disruptive assurance. We also note that, especially with our SME changes, that transformation and that first step within digital transformation is a key part. And we've noted a failure to launch concept where people are struggling to take those first steps, or a failure to land where concepts of digital transformation don't necessarily move out of the proof of concept phase. So we're all about creating that low risk environment where people can come and demonstrate return on investment with us and understand what it actually takes to be able to make a digital transformation. And so lift and shift or move from the NCC out and help to introduce those products and those processes into your business. So having said that, we set up this framework for how we go about developing our own facility. Now, what we want to do is demonstrate that we could do it so that you can learn from our failures and learn from our successes. And we basically use this framework of what we call the enabling capabilities. These are our test beds. They are really the IT and the OT backend and backbone of what digital is required in order to make transformation happen successfully. And it really is about us building this open access architecture, teaching others what we've done, the tools, the techniques, and the ways we've structured the different IT solutions to provide an industrially relevant solution. It is a factory. It has a pre-production, a production environment. It looks and feels like a full-scale production facility, but these can be tailored to support what your facilities look like. And that is one of the differences we can make. We can actually create a pre-production version of these test beds that look and feel and reflect what your facility looks like, so you can get that learning in a realistic environment. What we do then is also demonstrate how you could exploit a number of these enabling capabilities in the right way to get your industrial challenges met. And these are what we call our demonstrators, our proof of concepts. And they are there for you to come and have a look at. Come and look at what we've done, how we've actually utilized our enabling capabilities, so we can show you what to do, what not to do, what your make-buy analysis may be, and what return on investment you can achieve that is specific to your needs. And obviously, built in everything around that, the big skills gap that recognized in the Made Smarter campaign, we are there to offer a learning factory. We're there to offer an environment and a program of work that will help you take your workforce into the future and enhance them into those digital engineers that you need in your facilities. And we're also there working with STEM, HE, and FE solution, sort of colleagues to essentially promote what digital engineering looks like within the workforce and within the future workforce. So here's an example of what we've done on our first step of program. Pre-2019, we launched a program called ICAP. It was a major investment in the facilities at NCC, but part of that was also looking at exploring what digital brings to the table and what digital actually means. So trying to demystify and understand from ourselves what our requirements were. So this program was a very small digital's first step. It was us really understanding what our enabling capabilities would need to be and how we would go about architecting them and setting out the requirements for things like data warehousing, sensorization, analytics, and looking at these phrases and understanding how we would start to incorporate them in our business. We subsequently landed the 5G Encode project, led by a partner company, Zeta. Our lead partner is Zeta, a small startup within the Bristol region. And we are the innovation lead on that 5G Encode program. It is a £9 million program funded by DCMS as part of the Industrial 5G Testbeds and Trials program. And its aim is there to understand what 5G could unlock and the value propositions that it actually gives to manufacturing. It also allows us to build, using our architecture, that sustainable 5G platform and to really understand how others could take 5G and implement it at their own facilities in the right cases and in the right way. So if you look at our architecture, we have now and are creating, and will be ready available at the back end of this year, a reliable, low latency, high bandwidth testbed, which is built off that 5G technology. In fact, it's a wireless communication. It's built off a number of technologies from Wi-Fi to 4G to 5G. So you can look at what the flexibilities are and look at what those opportunities could be for you. It then looks to exploit those in 3 key use cases, which are VR, AR, immersive working and training, closed loop manufacturing, and in factory and out of factory asset tracking. So what could 5G as a collective unlock in those spaces, and is it actually relevant to fit with your business needs? The partnership, you can see, is fairly expansive. We work very closely with our colleagues in University of Bristol and the members of the industrial consortium that is engaged, bringing both technology to the table, but also the bandwidth and the telecommunications sort of facet. Okay, we then moved on in our journey and we have taken on a program called Detti. We're the lead partner for delivering that in collaboration with a number of members. Now, our collaborative partners are the University of West of England, University of Bristol and Bath as our research enterprise, bringing together the strength of digitalization in the region. So this is us at the NCC really looking outside the NCC and capitalizing on the strength that it offers. So we have a really strong research community with centers for doctoral training in the region. And we also have really strong research and technology organizations. So we're there as the factory. We have our Center for Modeling and Simulation partnerships who are bringing a lot of stuff around the IT infrastructure and model-based systems engineering and the design thinking into the consortium. And we've partnered up with the Digital Catapult, who are bringing some knowledge around asset monitoring, servitization, and the SME and technology engagements in those spaces. This is a co-investment model with industry, and the 4 industry parties who are involved at the moment in Detti are, as seen below, GK and Airbus, Rolls-Royce, and Siemens. Okay. Just to give you insights on our model, this is the Detti enabling capabilities. We have expanded them, so you get something around hosting. What does hosting mean? What does cloud mean? How do we exploit these secure facilities that are available on the market? We have modeling and toolboxes. What are these? What does AI unlock? What does digital modeling mean? What does high fidelity simulations? What does surrogate modeling mean? Everything in digital is around data. So how do we standardize the way we ingest data? How do we standardize how we can effectively make that data ready available so that we can get the startup community and AI engaged? We then look at how data lands effectively with people and talk about the human-computer interfaces. And this is a lot about where the research in VR and AR techniques are coming into the fray. But most importantly, we then look at how we thread the information together to maintain that digital thread across the life of a product inside a factory, outside of a factory, and forms a backbone of how we are then able to perform analytics across a wide range of data sets. Expanding on exploiting these things, we then have these 5 proof of concepts within the Detti. The left two around concurrent engineering and design intelligence really look at how we accelerate that product innovation cycle, coming back to our strategy. How do we start to work to bring AI, to bring solutions, digital technology solutions to accelerate that product innovation space? And then we have the made smarter type proof of concepts, which really focus on your manufacturing intelligence, getting sensorization, getting right first time into your factory and making sure that you can optimize your assets. We look at digitally enabled operations. How do we get augmented working, digital work instructions, all the things that you would see in that space. And then the asset management facet around, well, does this allow us to operate a different business model? What is servitization? What do these new business model looks like in terms of asset management, as well as the logistics optimization outside of the factory? Okay. Our third aspect in our framework is within the Detti is that big skills and workforce program. So we have a massive initiative around future generations, really inspiring primary and secondary within the STEM framework. We are working with our colleges and our universities to really transform how the educational landscape looks for the future in higher education. And we have an innovative workforce and development program, which looks at lifelong learning. Where are the gaps in our current workforce? How do we start to move our engineers of today into those digital engineers of the future? So we started off with a very small ICAP program, moved into the 5G program, which expanded our capabilities, and then expanded into a Detti, which is building on the strengths within the region, partnering up with the right people within the West of England, with the support of the West of England Combined Authority on this program. Here is an example of the sort of things we're looking at. Meet the Braider. This is a highly technological piece of equipment within the NCC. It basically spins and creates a braid of in this case, an overmold. And what we're trying to measure here is the in-process monitoring. So on the ICAP, this was a piece of the ICAP equipment that got purchased. We are now measuring the braid angles in process to understand what curvature means. Because if you come back to one of our philosophies about net zero or net zero manufacturing, what we want to do is to look at how stability is improved. So we're monitoring in process and making adjustments to the actual manufacturing sort of controls so that we can get improved stability, which therefore indicates less waste and therefore puts us on the target for net zero. So we took that and then we expanded and said, well, let's take the Braider, but instead of us doing it just at the edge on the programs that are sitting in the Braider, how would we start to communicate this information across a very secure link, because we didn't want people to tap into it, into a cloud-based or a decentralized control center. And so this demonstration is about taking the machine assets that we have at the NCC, bringing it into a cloud control center, which we've located at our Detti partner site, the CFMS, where they have high-performance computing and the capability to do quite large analytics. And in between, we've started to build the first first pre-commercial trial of quantum key distribution, a very secure way, multi-factor way or multi-secure way of communicating data across that network. So data sets are shared from our machines across this QKD link into the control center at the CFMS, where we were able to perform what we call cold path analytics. And then the data and the control codes are then pushed back and they are near real-time adjusted. Now, this is quite an interesting model about making sure we get security of inter-site communication protocols and really starts to unlock some ideas around secure remote working, which is going to be potentially part of a very interesting discussion around hybrid working in the future, which is key to our industrial green era. So this is just the start. It's the first pre-commercial trial supported by Toshiba and BT. Okay, here are some other examples. Now, there are a lot of them. We've got a number of case studies. We have case studies on VR, AR, immersive training, and we talked about those. We have an outreach program that we're running with our universities, and we have some optimization studies we're doing on composite tanks to support our hydrogen programs. These are the 5G use cases in the bottom right around time-sensitive asset tracking, closed-loop manufacturing, and also the technologies about slicing and splicing, which is coming in from our partner, Zeta. So please go and look at our websites and find out more. They're up in the top right-hand corner. What next then? Well, we've just completed a pilot on the Smart Factory Innovation Hub. This is one of the Made Smarter campaigns. We, as part of the HVMC, were invited to do a pilot to understand what an innovation hub could actually activate, and we have successfully deployed this. This is now an open platform for people to come and engage, and some of the first sprint project partners are indicated: Smartier, InSphere, IoT Horizon, came and we were able to integrate their technologies into our testbed and help them be able to industrialize and validate their solutions within a real working environment. Our testbed actually looks a little bit like this. It is an advanced preforming cell, which has a number of actuators and forming solutions in it. It's for a stringer type shape that has been loaned to us by Airbus. And you can see that we are able to plug in data visualization IoT platforms readily easy. We set up the cell so it's open, so you can come in and you can add your systems to this thing if you're a technology provider. If you're an industrial use case owner or challenge owner, like Airbus would be in this case, you would go and say, I'm interested to see how I can enhance my forming process and put the challenge into this test bed. And so, the technology community or the tech community can start to engage to see how they can help industrial challenge owners to solve their problems in a real working environment. Okay. So that's the journey we're on so far. We've got a number of lessons learned, and I've tried to summarize them at a high level in this slide. What have we done? Well, when we started pre-ICAP days, we had the engineering operations, the IT operations, and a big wall in between them. And both of them were running business as usual activities. And it was very difficult to understand how digital could operate, because digital is this unique mix between the engineering knowledge set and the IT capabilities that a business needs. So what we've done is we've refocused our engineering teams of today, and we started to evolve them with more digital integration and digital skill sets, understanding the technologies, understanding how to acquire data and integrate their machines and their variables into the actual IT systems. On the right-hand side, we've done the same thing about our IT organization, rethinking about how a business as usual or a standard production IT organization would evolve into more of a test DevOps kind of IT solution. And by doing that, we've now created in the middle something which has punched a hole in that wall and created new skills for both the engineering and IT sets, new processes that we need to put in place, and then establish some combined skills and processes that both teams need to have in order to communicate more effectively. One of these is really about looking at the enterprise architecture that will be needed in order for us to have a test and DevOps environment space or development space where the engineers can come and play, and then have a really strong protocol by which we can move from that DevOps space into our IT operations as usual. I think it's really important to note that we wouldn't be anywhere in our programs today without a significant sponsorship coming in from our CEOs. So it's very critical that you get your CEO bought into the concepts, understanding the value proposition they can offer, and being there at the forefront promoting it. We also have been successful with a number of strategic and regional investments. So big thanks to DCMS, WECA for the investments into the Detti and the 5G programs, respectively. Without those investments, clearly you can't progress. But what we've created is this testbed where industry can come and work with us. It is there as an open access. It's funded by government and is there to showcase how you could transform your own facilities in that low risk environment. One key thing I also want to note is our team, the team that we've created in the middle. They have a very different mindset to how a normal business as usual team will operate. They're happy to sprint, they're happy to fail fast, and they're happy to learn from those failures. And they have a real willingness to explore how digital can actually enhance and understand. And it's all driven from business benefit. It's not, let's create something because it's nice, let's create something because it really makes a difference to the way we at the NCC operate, but also because we think it'll create a massive difference to the way industry operates. And effectively, some of these, if not all of these proof of concepts, are pulled from industry requirements. And that's all I really want to say. Thank you very much for my time and the opportunity to showcase what we've done at the NCC. My name is Marc Funnell. Please contact me. We're really happy to learn about what you're up to. We hope that you can come and engage in our test beds. We have the 3 that are sitting there at the moment. They're ready to go. They're ready for you to exploit. And we're interested to hear your transformation journeys and see if we can help you along the way. Thanks very much.